Hello, in this video today we are going to talk about the recursive process. Excuse the bell. We're going to talk about the recursive process to represent an arithmetic sequence. Please remember to go ahead and write down the objective for today. For prior knowledge, I'm going to bring back in a growing dots problem. And here at the beginning we have one dot. After 1 minute, we have 1, 2, 3, 4, 5, 6 dots. After 2 minutes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 dots. And last week we talked about arithmetic sequences where we add or subtract numbers. And here you can see that the dots are growing by 5 dots for every minute. We went ahead and calculated an explicit formula by saying the number of dots is equal to, 5 dots for every minute plus our initial value here, our f of 0, which is 1. So I have 5m plus 1. Now if I wanted to figure out how many dots there would be at 3 minutes, it's easy to just go ahead and say, okay, well at 2 minutes I know I'm going to add 5 dots per minute, so 11 plus 5, that is 16. So here we will have 16 dots, and after 100 minutes, though, that would take a lot of work, right? So we can calculate f of 100, which would be equal to 5 times 100, squeeze in an extra 0, plus our 1 dot that we initially had. So there will be 501 dots after 100 minutes. That's kind of what we did last week. For today's lesson, we are talking about a recursive process. We want to represent the arithmetic sequence with a recursive process. So the first thing we need to talk about is the root word here, and this is recur. Recur means to repeat. And some examples of this, here I have 2, 4, 6, 8. Who do we appreciate? Schwarberg. Schwarberg. Yeah, Schwarberg. Right? That is recurring. Here's a non-example, -1. 5, 20, 13, -15. There's no pattern there, correct? 3, 6, 9, 12. Okay, that's a recurring arithmetic sequence, right? We have things that are recurring. And then again, here's a non-example. So a recursive process, and make sure you get this in your notes, a recursive process is a process that uses the previous term to find the next term in the sequence. So we're going to use the previous term in order to find the next term. And that's why it's called recursive, because we're repeating patterns. In order to create a recursive process, here we're pulling back in our growing dots example where we had 1 dot, and then we had 5 dots, and then here we had 9 dots. And we can represent this in a table, right? So in the beginning, there's 1 dot. After 1 minute, there's 5 dots. At 2 minutes, there's 9 dots. 3 minutes, there's 13. And this kind of just represents what's going on. And here's our explicit process, right? 4 dots per minute plus the 1 we initially had. Well, we're going to take our input, we're going to call that f of 0. You guys agree our initial value is 1 dot. At 1 minute, we had 5 dots. So essentially, right, f of 1, our first term, is that 1 dot that we had plus the 4 dots that we had. And I'm going to take this 1 here, and I'm just going to substitute that with f of 0. So really, f of 1 is f of 0 plus 4, the 4 dots that we had. Here I have f of 2. At the second minute, right after 2 minutes, we have 9 dots. Well, we got those 9 dots by adding 4 dots to the previous 5. And really, the 5 dots that we have is f of 1. So f of 2, our second term, is the first term, right, the previous term, plus the 4 dots that we had. And this keeps going. F of 3, at 3 minutes, we have 13 dots, right? We added 4 to these 9. And now I have 9 dots, right, the 9 dots, plus the 4. Well, if I substitute this 9, because we had 9 dots at 2 minutes. So f of 3 is f of 2 plus 4. And I hope you start to kind of see a pattern here. F of 4 equals 17. Well, we got that 17 by taking the 13 dots right here at 3 minutes and adding 4. So f of 4 is f of 3 plus 4. And what we have developed is here kind of a pattern. Notice the term that we want is the term that we had before, and then we add the 4 dots. So if I want any I guess you could say the amount of dots at any given minute, I'm going to represent that with x. So f of x is equal to, well, the amount of dots at the previous minute, right, x minus 1 plus 4. And I can connect this to this. I'll give you as a concrete example. Say I wanted the amount of dots at 100 minutes. Well, that would be the amount of dots at 99 minutes. Well, isn't, and I'll write this down. So, for example, if I wanted f of 100, well, wouldn't that be the amount of dots I have at 99 minutes plus the 4? Well, 99 is really what? 100 minus 1. You guys all see how we always take one less term. So here we're subtracting, and then we add the 4 dots that we have. This is what is called the recursive process. Okay, and that's our objective for the day, is to represent an arithmetic sequence with a recursive process. So here's our skill. In order to create a recursive process from an arithmetic sequence, we're going to identify the first term and name it with function notation. So the first term is always f of 0. F of 0. Okay, that's our very first term, or our initial value. Then we're going to identify how the outputs are changing and represent this recursively. So in this situation, the outputs are changing by the common difference, right? How we're adding or subtracting each minute. That is our changing process. Okay, this is our recursive process. For our first example here, we have 175, 150, 125. Please write these down in your notes. These are left blank. And we want to create a recursive process from the given pattern. So what we need to do is find f of 0. F of 0. And I really don't like this first term. Please cross that out. We're going to write initial value. Sorry about that. Initial value. Because here, 175, that's our first term. This is a list, right? I want f of 0. So I can't find that first. I need to find the common difference. And here, you'll notice that my values are always decreasing by 25. So my f of 0 value is really going to be 200. Okay, so I have f of 0 is equal to 200. Okay, then I need to find f of x. Okay, well, I know f of x is f of x minus 1. And to find the next term, I'm just going to replace the common difference. And here our common difference, I'm going to say d, if you will. D is equal to negative 25. So I'm subtracting 25. This is our recursive process. This is what we've done. That is our objective for today, to represent an arithmetic sequence, given here, with a recursive process. That's a 0. Next example, please write down these values. In our next example, we have 17, 28, 39. I need to go ahead and I need to find f of 0. I must find this guy, and I must find the common difference. And again, scratch that out. That's the initial value that I want to find. So since this is f of 1, in order to find f of 0, I have to go back a term. So 17, 28, 39. Well, here we are adding to this. This is going up by 11. Here, 28 to 39 going up by 11. Okay, so it's arithmetic. I'm going up by 11. And going back a term, this is going to give me a value of 6. So, writing my arithmetic sequence is going to be f of 0 equals 6. Next, I write f of x equals f of x minus 1, the previous term, plus my common difference. And my common difference My d value is 11. So I say plus 11. And that's it. What I hope you notice thus far is that the recursive process, it has two lines, and that they are stacked. F of 0 and then f of x. All you do for the recursive process is you drop in your f of 0 value, which I put in red, and you add to the previous term, f of x minus 1, your common difference, or you subtract if you're subtracting. Let me backtrack a second. I would like you to go ahead and please do this problem on your own. Please pause the video and do this problem on your own. Okay, hopefully you have done this problem on your own. F of 0, that's our initial value. Here we're adding 7, so if I was to go back, my f of 0 term would be negative 16. So f of 0 is negative 16. That's what we dropped in. And our f of x minus 1, sorry, our f of, backtrack this, our f of x term is f of x minus 1, plus our common difference here, which is plus 7, which is what we added in. That is our answer for today. Here's example 4. Please go ahead and try this problem on your own. Okay, hopefully you've tried this problem on your own. Our f of 0 value, we need to go back. Here we are adding 20 each time, so d is equal to 20. Going backwards to get my f of 0 term, it would be negative 15. All I did was subtract 20 from 5, giving me negative 15. Okay, that's our f of 0 value. And to find f of x, well, that is f of x minus 1 plus our common difference, which is plus 20. This was what we were doing for today, representing an arithmetic sequence with a recursive process, repeating process. Okay, where we're going next with this is we're going to start with our f of 0 value, and we're going to find terms by identifying our common difference. Okay, thank you for watching. Please like, subscribe, and I will see you next time. Schwarberg out.